Good evening, everybody, and welcome to the last session. We will be hearing about mechanical engineering this evening. Thank you for attending the last few evenings. I know that many of you attended all the sessions. We've had lots of good queries, and just know that you can always send me an email if you have any queries during the next few weeks, and we're always there to help. Thank you for the support, and we hope you enjoyed this evening session. Without further ado, I'll hand you over to Prof. Glen Bright, the Dean and Head of School of Engineering. Prof. Bright.
Thank you very much, Swasti. Can you hear me all right?
Yes, we can. Thanks.
Thank you very much. And a very warm welcome to the parents, pupils, boys and girls, fellow staff, and other people who have assisted. Today is our last session. We started on Monday with the chemical engineering, civil engineering, and electrical, electronic, and computer engineering. And today we'll be doing mechanical engineering. As a dean, I'd also just like to express my thanks to Sally and Swasti, who have put the series together of open days for the School of Engineering at UKZN. Thank you very much. They've gone very well. And tonight we are going to also be having a good session, an exciting session for the people who join us. So, as has been mentioned, I am the Dean and Head of School. And at UKZN, we have 4 clusters of engineering. We have 7 disciplines. So the first cluster, if you want to call it that way, is mechanical, which you're going to be hearing tonight, mechanical engineering. We have a cluster in chemical engineering. We have a cluster of electronic, electrical, and computer engineering. And then we have a cluster of civil engineering, agricultural engineering, and one other discipline, land surveying, which is in the civil engineering cluster. So, first of all, what I want to talk about is why would one want to do engineering? And that question must have been raised by people who are thinking about doing engineering, pupils, boys and girls. And the real answer to that question is that engineers solve problems. If you like to solve problems, then the chances are that you want to be an engineer. So years ago, when man was first covered the earth, they wanted to travel from one point to another. So they had a problem. In order to solve that problem, they built motor vehicles, they built railways, they built aeroplanes, they built ships over the years. And these are people who did this are called engineers. Essentially, what engineers do is they build the infrastructure of a country. So if you have a look at a country which is very successful, like, for example, the United States, Western Europe, Japan, Australia, these kind of countries have good infrastructure. They have good infrastructure because they have a lot of engineers who are building the infrastructure. So the infrastructure is not only factories and buildings, it's also roads, bridges, it's also buildings, of course, vehicles, ships, aeroplanes, etc. So basically, almost everything you use is somewhere along the line being designed and built by an engineer. And essentially, engineers are the cornerstone of an economy. Engineers create wealth. So countries that are very wealthy, they have a lot of engineers. Countries that are not so wealthy, they don't have many engineers. So engineers essentially create wealth. The next thing you need to ask yourself is, where would you like to study engineering? So if you want to do engineering, you like to solve problems, the next thing is to study is, where would you like to do engineering? Now, my strong suggestion is that you do it at an accredited school. Now, a university is not accredited. A degree is accredited. So if you have a medical profession or an accounting profession or law profession, these professions are governed by a professional body. And the professional body for engineering is the Engineering Council of South Africa. We call it ECSA, ECSA, and that stands for the Engineering Council of South Africa. And they are the professional body that accredits degrees of engineering at higher institutions in South Africa. So all the degrees at UKZN in engineering are accredited. They have been since the beginning of accreditation, and they are still accredited as we speak now. the accreditation, which is an evaluation and an audit process done by the Engineering Council of South Africa. There's signatories to the Washington Accord and to the United States. And this is the highest accreditation body or process that a university can use to accredit its engineering degrees. So all degrees, all 7 disciplines, electrical, electronic, computer, civil, agric, mechanical, and chemical engineering are accredited by the Engineering Council of South Africa. The next thing is about your career. You know, what kind of a career do you want? And there's no doubt that everybody, as you're leaving school, wants a rewarding career. You want a career that's going to be exciting. Of course, you're going to need to be able to make some money, of course, but you also want to enjoy your career and enjoy your life and bring up a family and an environment where it's very, very stable. So engineering really gives you that. Engineers earn very good salaries. They, of course, have a very good lifestyle, but also they work hard and they solve problems, as I said before. The next thing to consider is the curriculum. Now, the University of KwaZulu-Natal School of Engineering has gone through a curriculum transformation phase. We are currently updating and are near the end of updating and are finishing updating our curriculum in all disciplines to align it with the 4th Industrial Revolution. Why are we doing that? We're doing that because we want to make sure that the curriculum that a pupil or a new student takes is up to date and you are ready for the market, which means when you graduate that you are market ready, the market wants to employ you, or you want to continue and do a postgraduate degree at master's or PhD level. So we have a number of our staff here today from mechanical engineering who can answer questions. Questions can be asked at any time. You just use the chat feature at the bottom. So at any time on the chat, you can ask a question and one of my staff or myself will answer any question you have regarding mechanical engineering. It can be about the degree, it can be about the career. The questions can also be about admissions, enrollments, etc. I'd like to end off by saying that yes, you do have to be good at maths and science. Okay, maths and science is a prerequisite. You have to be good at it, and it's also an advantage to enjoy maths and science. It'll make your life a lot easier. So please have a look at our website. We have a very informative, up-to-date, exciting website. In fact, I was on it a few minutes ago. The website's very informative, and it demonstrates not only the subjects that you can do, it not only shows you the staff who are involved in the curriculum, but also some of the flagship projects. And there's some very exciting flagship projects. These are major projects that have been undertaken through the School of Engineering. And I'm sure tonight you're going to hear about 1 or 2 of the major projects from mechanical engineering. And I suspect that we're going to be hearing about the aerospace rocket propulsion project, which is very exciting. Okay, so with that, as the Dean of Engineering, thanks again for joining us. A very warm welcome. And I'm going to now hand over to the academic leader of mechanical engineering, Professor Glen Snedden, to take you further. Thank you.
Thank you, Glenn. Let's get the screen sharing. And that clearly isn't working. Right, hopefully you can see my screen. Can someone just confirm that for me, that you can hear me and see my presentation?
Yes, thank you, we can.
Great. Right, so yeah, welcome to a little tour of mechanical engineering and what it's all about. My apologies if there's some repetition from what the Dean has said. And in case you're wondering, you don't need to be called Glen to do mechanical engineering. The Dean himself is a mechanical engineer. And we first are going to have a look at what mechanical engineering is. Many of the young students entering mechanical engineering sadly come into mechanical engineering thinking they're going to learn how to fix cars. That's very definitely not the case. Mechanical engineering is a profession. It's a profession in which we use maths and science to develop, design, manufacture, and maintain mechanical systems. There are many, many areas in which a mechanical engineer can work. Air conditioning and HVAC, appliances, infrastructure development, biomedical, fluid mechanics, and all of these areas are actually specializations of mechanical engineering. And these areas are not necessarily specifically taught as part of the degree. We give you the foundation, and in many cases, you will go into industry with that foundation and grow your skills in a particular area. But these definitions are very wordy and off-putting. I rather prefer the more whimsical version given by Terry Pratchett. They had dreamed in a way that people usually use the word, had not dreamed in the way that people usually use the word, but they had imagined a different world and bent metal around it. And that, to me, just sums up how engineers think. They take an idea, a dream, a possibility, and they create it from scratch using the tools at their disposal. And I just want to reiterate what the Dean has said. Engineering is critical to growing the economy. We've heard recently from President Ramaphosa how critical it is to grow the economy and how important it's going to be for our future as South Africa. And you're not going to achieve that without engineering. There is always going to be a strong drive for growing the engineering base in the country in order to grow your economy, to grow your jobs. So I'm just going to take you on a little tour of what mechanical engineering is at UKZN and how we have dreamed at the discipline of mechanical engineering in UKZN. And those are just two of the more successful projects that we have undertaken in the last few years. It's probably fairly little known, but it was our car, UKZN's car, that won the challenge in South Africa and went over to Australia to compete in 2016. And we currently hold the altitude record for a hybrid rocket. That we did in 2020, and when we made it just shy of 18 kilometers. And those are the projects, but behind those projects are the engineers who have dreamed. And those are the two teams. And these are largely postgraduate teams by the time you get to breaking the record, but they all started off as smaller engineering projects in their fourth year at university. So let's talk a little bit more about how you become a mechanical engineer and what mechanical engineering means at UKZN. Firstly, we offer a Bachelor of Science degree in mechanical engineering. So you would graduate after 4 years with a BSc engineering degree. So it's an automatic honors degree, if you like. Secondly, as mentioned before, it's an accredited degree. It's a 4-year program, fully accredited by EXA until 2024. What happens in 2024, you ask? Well, we get reaccredited. And we are very, very confident that that will happen. I myself am an EXA accreditor. Obviously, I don't take part in the accreditation of our own degree, but we have plenty of experience with this accreditation, and we know the quality of our degree. Secondly, our degree is based on the Howard College campus. And that means it's local to UKZN, don't have to go anywhere. It's right here in your backyard. You can get a world-class degree and work anywhere in the world afterwards by going to university right here in Durban. Yes, you do need to get good marks in maths and science, and certainly English will help. And you need to get a number of points, a healthy number of points to make it into the degree. So let's look at how you launch your career by going into the degree at UKZN and what kind of subjects you will study. Now, your first year is a very broad introduction. It's the same across virtually all the engineering disciplines with one or two tweaks here and there. You will do a little bit of engineering materials and design, but you will do the fundamentals of chemistry, mathematics, applied mathematics, and physics. It is a heavy mathematics degree. But we speak the language of mathematics a bit differently as engineers. We turn those things into practical projects, practical products and infrastructure. So from second year, you will start to specialize in mechanical engineering. Now, what does that mean? And I'm going to, as the Dean had suggested, I'm going to use our own project, my own research group, which is the Aerospace Research Group's project, to have a look at what that means. But you can draw examples from any one of our areas, from robotics, manufacturing, energy, biomedical research that we are doing in the department actively at our postgraduate level. And we're going to use a hybrid rocket to explain those subjects in mechanical engineering. So the first one you're going to do is design. As I said, an engineer uses maths and physics, but differently. A physicist might produce a fractal or look at some interesting corner of physics. An engineer will take that interesting corner of physics, figure out how to use it in practice, and turn it into a product. In this case, there's our Phoenix rocket. That's the rocket that broke the altitude record. And every single aspect, every shape, every nut, every bolt, everything on that rocket has been designed according to the principles taught in second, third, and fourth years. Strength of materials. The analysis of the breaking point of materials, when it will start to stretch, when it will tear, break. And that's an injector module that's been designed, or tank bulkhead, it's an integral unit. And it's designed to take 20-odd bar pressure while mounting various components on it. Dynamics. This is an example, a very specialized example of dynamics. This is flight dynamics. Predicting and tracking the rocket as it is launched from the Overberg test range. You have to guarantee where this rocket will land up. And you can very easily end up with a rocket that does some very interesting things if you're not careful. So you need to predict where it's going to land and make sure that it lands within the safety footprint of the range. But there are other aspects to dynamics. There's vibrations and mechanisms such as two lever mechanisms. Your windscreen wiper on your car is a dynamic mechanism that needs to be analyzed and designed. Material science. This is an example of the actual hybrid rocket motor that sits in the back of the rocket. And all of these materials need to be integrated together. You need to know that they don't react with each other unless you want them to react with each other. You need to know that they have the right properties to contain all the forces that are going on in there and survive the temperatures that this rocket motor sees. Mechatronics. Many universities offer a mechatronic degree. We offer it at postgraduate level. And it's integral to our course in terms of the subjects you will do in third and fourth year. But this is a mechatronic mechanism on the rocket. The valve that is used to open the oxidizer line into the rocket motor is controlled by an Arduino board, and it's a mechanical device with control, which is essentially what mechatronics is. Manufacturing. This is the high-pressure oxidizer tank. This is a very specialized form of composite manufacture using wound composites, but you will learn all about conventional means of manufacture as well as the newer additive manufacturing techniques, which are increasingly forming part of our degree and part of the industrial revolution, fourth industrial revolution. Fluid mechanics, obviously it's a rocket, there's a lot of fluid mechanics going on. There's the aerodynamics of the rocket itself, but there's also the fluid mechanics of the injector going into the combustion chamber. Very complicated flows that can be analyzed using modern techniques. And finally, thermodynamics. This rocket sees 35 atmospheres and 3,000 degrees Celsius coming out of that rocket motor. So there's a lot of high temperature effects. The design of the nozzle, for example, all part of thermodynamics. The fundamental laws of the universe, all thermodynamic laws. So what do our graduates do when they complete their degree? Well, they work just about everywhere. Any industry you can think of. You know, we might think of the petrochemical industry as being the domain of chemical engineers, and so it is, but there are a large number of mechanical engineers that go into that industry. Maney Water, Eskom, they all require mechanical engineers. In fact, you can probably trace some of our problems in this country to the lack of mechanical engineers working in these environments. So there is a great demand for engineers. Some engineers or graduates will stay on and do postgraduate research, either an MSc or even carry on to do a PhD. And here they will work in one of our research groups, which at the moment is largely focused around mechatronics and manufacturing and aerospace and energy. But there are also research groups in biomedical and drones, for example. And we do some materials research. In fact, it's very little known thing, but UKZN now has the largest aerospace research group in the country. So while you cannot do an aeronautical engineering degree here, which is really a specialized version of a mechanical engineering degree, and you can do that up on the reef in Wits, but ours is actually the biggest aerospace research group in the country. So engineering is really a very scarce skill, and I think we've talked about that. And we are certainly amongst some of the highest paid graduates in South Africa. And it's a professional degree, and your skills can be used across the globe. So if you're good at maths and physics and you have a dream of designing the next big product, then why not come to UKZN and join in our dream? And really, the sky is the limit. So there is our website, and there is the sky is the limit. There's our rocket launching on its way up to 18 kilometers. But I also want to just take this final slide, just a mention of what's coming. The Girl CAD initiative is starting up again, and I really want to encourage you to participate in that if you are one of those young ladies who is concerned about doing engineering because you've not had the opportunity to do engineering drawing at school. It isn't a problem, and we are offering a crash course in it. And I also want to say that as of next year, I'm hoping we will start up our engineering winter schools. That's exactly how I ended up an engineer, was going to an engineering winter school at UKZN. And you'll be able to interact more hands-on with what the course is about. And it might be too late for some of you. You have to make your decision now, but I would encourage those that have a little bit more time to actually take those opportunities. Thank you very much. All right, so I need to stop sharing my screen and take the opportunity to introduce Ingrid. Ingrid Botha is a young lecturer, just joined us in the department, and she will definitely be one of those young minds, brilliant young minds, that is going to take our lecturing into the fourth industrial revolution. And I just want to welcome her to share our video.
Thanks, Prof. Snedden. So next up, we have a video of one of our flagship projects here at MECEng, which is the Phoenix Hybrid Sounding Rocket created by the Aerospace Systems Research Group, also known as ASREG. An interesting fact is that this rocket holds the hybrid rocket altitude African record of 17.9 kilometers. So without further ado, I will share our video so everybody can sit back and enjoy.
Three, two, one. What a feeling!
Come here to Denel Overberg Test Range because it's a world-class facility, great place to experience the flight test environment, and our students get tremendous experience as they move from the laboratory into the real world. My name is Mike Brooks. I'm the program manager for the Phoenix Hybrid Rocket Program. The reason we build these rockets is because it gives our students in ASREG a great experience in aerospace design, propulsion design, and importantly in flight testing. The aim of this campaign is to test two rockets. We've got the Phoenix 1B Mark II-R, which is our high-speed rocket, and we're going to try and break the African hybrid rocket altitude record with that vehicle. And the second rocket is a Phoenix 1B Mark I, which is more a test platform to fly telemetry systems, recovery systems, and that will be a low altitude shot, and we intend to learn as much as we can from both of these flight tests.
Today we're launching the Mark II rocket, which is looking to break the South African hybrid altitude record of about 10.3 kilometers. So this one we're going to push to about 18 kilometers today, depending on wind. My name's Kai Broughton. I'm the lead engineer on this Phoenix hybrid sounding rocket project. I'm leading a team of approximately 10 engineers working part-time.
Ready on your mark. Everybody stand.
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Ignition.
hopefully that was as inspiring to our viewers as it was the first time that I watched the video about the hybrid sounding rocket. So next up, we have an account from one of our past students, which I'm sure many of you are interested in hearing, and how exactly the experience of UKZN has shaped him. So may I please welcome Mr. Jashveer Biputh. He is currently a registered professional engineer working as a senior mechanical engineer at Wood PLC, which is a tier 1 consulting company. He graduated in 2012 with a BSc Mechanical Engineering, kicking off his career at ArcelorMittal, South Africa. Since then, he's worked at Oricon, Hatch, and Wood PLC, where he's currently working on the design of material handling systems, which are applied globally to mining projects. So without further ado, if I may please welcome Mr. Biputh. If you can just unmute your mic. Yeah, perfect.
Sorry about that. Thank you.
Awesome, thank you.
Thanks. Firstly, I would like to thank UKZN for giving me this opportunity. So I've prepared a little presentation as discussed. Okay, so yeah, once again, I'd like to thank my colleagues at the University of KwaZulu-Natal for giving me this opportunity to present basically my experience at UKZN and how it shaped me as an engineer thereafter. So my name is Jashveer Biputh, and yep, this is my presentation. So basically, I'll start with a small introduction of myself, my professional background, what I do. I'll briefly touch at my time at UKZN. It was quite a while back now, but I'll try to remember. And then we'll go through what a mechanical engineer does from my point of view. So I want to start with a small icebreaker. So I think many of my engineering colleagues on the call will understand this. Our social skills are not the best. They say you don't study engineering to be the life of the party, but we get by. Okay, so just a small introduction to myself. I'm 31 years old. As mentioned, I got my BSc in engineering, mechanical engineering at the School of Mechanical Engineering in UKZN. My final year was 2012, so about 10 years ago. Matriculated in Biputh Secondary School, which is in a small town north of Durban. If anyone in the chat is from Biputh, give me a shout out. And currently I live in Gauteng in a town called Biputh, and that's how I look. Okay, I'll just give you a small journey of my career into engineering. So as I said, Biputh Secondary School, matriculated 2008, engineering degree 2012. First started work at ArcelorMittal, South Africa, which is a steel manufacturing plant in the south of Johannesburg. It's the second biggest steel manufacturer in the world. I received a bursary from this company. That's why I started here. And just a piece of advice for all the learners, I would suggest please apply for the bursary. Look for it while you're still in school. I think it will really help a lot, especially for getting into the job market, if that's what you want to do when you finish your degree, like I did. Spent 4 years there as a mechanical engineer, moved over to Oricon, which is a consulting company. Spent about 2 years there as a mechanical engineer. I had an opportunity to move to Hatch about 2 years after that as a materials handling engineer, which I shall explain more about what that entails as we go through the presentation. Just in between, while I was working at Hatch, I received my professional engineering registration, which I shall also explain a bit later in the presentation what that's about. And then currently I'm a senior materials handling engineer at Wood PLC. Yeah, okay, moving on. So my time at UKZN. So yeah, first year started in 2008. Actually, this is a mistake. It's 2009. I graduated in 2013, my final 2012. Favorite module was strength of materials. I think Prof. Snedden touched on what that entails. This book here will be quite familiar to most of you if you do choose the route of mechanical engineering. Many sleepless nights. Yeah, final year project. I did the hybrid golf cart. Final year project, external moderation. I actually did one this afternoon. So your time at UKZN doesn't really end even though you leave, which is, I believe, is a good thing. Okay, so what does a mechanical engineer do? So first of all, I think this is a great platform for young learners. I don't think I had it when I was at that stage, but when I was in school, like most of you are, this is what I thought mechanical engineering was about. I thought I was going to work for a Mercedes F1 team. Obviously, some still do. And then later on, you think, okay, maybe you're going to make a Falcon 9 rocket like Elon Musk. Or if you ask my parents at the time, they'll probably tell you you're going to be a car mechanic, which is totally not right. But what do mechanical engineers really do? So it's mechanical engineering is actually one of the broadest fields of engineering that you can find. So some of the careers, and we can read it on the left-hand side as such. But I think in the South African perspective, if you're looking to stay in this country and work, I think the major career paths that you take is either automotive, where we have a number of automotive plants in the country. We have Mercedes-Benz in East London. We have Toyota there in Durban. There's BMW in Roslyn, Pretoria. Energy, Sasol, one of the biggest petroleum companies in the world. Groundbreaking technology being used there, just all here in South Africa. Manufacturing. We have major manufacturing companies, as I mean, like ArcelorMittal for steel. We have fast-moving consumer goods in the form of Unilever, RCL Foods, etc. And then mining, which is a big part of South Africa. We have Anglo-American, Exxaro, Sibanye-Stillwater. There's major scope there. Some of the stuff that you'll be doing as an engineer. And when I was writing this list up, I was thinking about how UKZN actually helps you to achieve this. And then I was thinking about how each one of these bullet points you actually achieve when you do your final year project at UKZN. You start with your conceptual design, you have to do your analysis, presentations, there's multidisciplinary teamwork, there's prototyping, testing, there's research, you have to do analysis. So I think, and from a mechanical point of view, UKZN really hits the mark in terms of preparing you for the working world. Moving on. So what I used to do, this is just a small side of what the different types of engineering you can do when you start working. So I started life on a plant. So this is ArcelorMittal South Africa. It's one of the biggest plants. I think it is the biggest steel plant in Africa. This one in particular. It's a dirty place. You can see this is me, one of my good days. So some of the tasks I used to do is preventative maintenance. Basically, how do you stop one of the pieces of equipment from failing before it actually fails, and then you have to fix it. Maintenance planning, it's something to do. It's the same sort of thing. Continuous improvement. How can you keep on improving the plant? So it's nothing written in a textbook. It's just something. It's the skills and the lessons that you learn at UKZN that helps you to achieve this. Failure, root cause analysis. When something breaks, you don't want it to break again. So you need to do some analysis to make sure that it does and put actions into place. And then obviously project management if you're doing projects and that sort of thing. So that's what I used to do in my previous life. This is what I do now. So they what call me in the industry as a bulk material handling engineer. So essentially I design systems in mining and sometimes manufacturing areas where we transport material, such as ore in the mining industry. So basically you start off with a layout of a conveyor. For example, this is a conveyor. Then you do more engineering on it. And then you come an analysis. Also do some simulation work. This is what we call a transfer tube. So one conveyor to another conveyor. So in my line of work, I will do the analysis on this using software and optimize the piece of equipment in order to get the optimal flow. So it is still exciting stuff when you leave university. So I just want to touch on some of the highlights of my engineering career so far. So I talked about being a professional engineer with the Engineering Council of South Africa. So a professional engineer is basically a certification that you get from the Engineering Council of South Africa when you have demonstrated that you have achieved certain outcomes that are prescribed by ICSA. So in the course of my career, and it usually takes in a medium of 5 years or so, and then you are judged by a panel of your peers, and they sort of give you a final. Sorry, I think someone's on the mute there. Yeah, so in any case, what I was saying is you are judged by a panel of your peers, and then you are given this the certification. And in the workplace, how it gives you an advantage is, of course, it comes in some areas, it comes with a monetary advantage, but it also gives you more responsibility in the workplace. And from a legal point of view, you're also termed as responsible for designs, and you can sign off designs for construction, etc. So it is something that I think as any engineer should strive for. And then lastly, the other thing that I'm quite a highlight for is mentoring. I think this year, my involvement in this falls under that. I think engineering as a career, it gives you an opportunity to how can I say, be able to pass on knowledge to younger individuals. And I think that's given me, this career has given me the opportunity to that. So I'm quite grateful, and it's made it more fulfilling as well. And then lastly, I got a little quote here from quite a famous astrophysicist. I think what we usually consider as impossible are simply just engineering problems. So I think if you're sitting in this forum and you want to get this and you're interested in engineering, I think you've made the right choice. Engineers do things on a daily basis that no one would ever dream of. And I think if you get into this field, I guarantee you'll find it very fulfilling, and you won't make a mistake. And then lastly, maybe in a year's time, you'd be you'll be sitting at Christmas and boring your family about all the cool stuff you're learning at university. Thank you. That's all for me.
Thank you very much, Mr. Biputh, for your inspiring account. I hope this has given everybody a taste of the exciting things that wait for you here in mechanical engineering. So whether it is rockets, cars, robots, or hovercrafts, there's no dream or idea too great or too strange when you come and study in mechanical engineering at UKZN. And over and above that, our facilities allow you, whether it's the lands, the workshops, or the labs, allow you to achieve these dreams and make these ideas a reality. So that ends off our presentation for today. Next up is, what do you do next? So here I've given some handy tips of who you can contact regarding your applications or further inquiries. You're also welcome to still type your questions into the chat. And if I can please ask all of our viewers to complete the compulsory poll before you leave the session today. So that gives us some feedback on how the presentation went. And last but not least, I'd like to thank all of our speakers as well as our viewers for attending this evening. So thank you very much. If you want to choose the poll, it should be popping up on your screen now. Thank you very much.